Hello, and in this one of the dasim tutorial videos, I want to introduce the new layout feature. Usually, after you've simulated a circuit and got it working, at least in theory, the next thing to do is to build it and check that it works in real life. And that involves either a breadboard or a stripboard type of construction technique. dasim now has some tools that will allow you to check a breadboard or a stripboard layout. Let's start by having a look at perhaps the simplest circuit I can think of. This is just a 1K resistor connected between 12 volts and ground, so it should have 12 milliamps flowing through it. Now, if we wanted to build this, we would first have to select whether we wanted a breadboard or a stripboard construction technique. I'll start by looking at a breadboard technique. To do that, we would go to the Sim Controls, select the Layout tab. A window appears at the bottom here, and then I would select on this side probably small breadboard. That should be plenty big enough for this circuit. A breadboard appears. You can zoom up and zoom down using the mouse wheel, and load in the components by pressing the Load Components button. That brings in the resistor here. It also brings in a connection block, and the connection block has holes which represent the connections to the outside world. In this case there are only two of them, a 0 volts and a 12 volts in the circuit. You can put wires on a breadboard by starting to click at any hole. Just press the mouse button down and hold it down and then drag away, and a wire will be created, and you can drag the other end of the wire wherever you want, drop it. If it happens to drop on a hole, then a wire will be connected between those two holes. If it happens to drop somewhere that isn't a hole, the wire will vanish. So, let's put our resistor there. We can extend the leads of the resistor, but it's usually not a good idea to extend them too much. For the point of view of making a neat layout, we want to keep the wires short if we can. Then we'll connect a wire from the 12 volts to one end of the resistor, and from 0 volts to the other end of the resistor, and that should have wired up our circuit. You'll notice that whenever I take a new wire, the colour changes. The next colour of the wire appears in the wire colour box there. If I didn't want a yellow wire there, and I didn't want a green wire there either, you can click on the wire colour box until it goes round to the colour that you do want, and then draw in that wire, in this case black. There's also two junctions in each wire, so they don't have to go in straight lines. They can go in zigzags to go round other components, if that makes things easier. I'll just drag this end off the breadboard to remove the wire. Now, to check that my layout is correct, I can press the Check Design button. And it says, no issues found, it's happy. Note, it doesn't matter which way round you connect the resistor. It's still going to be happy. The resistor is not a polarized component. It's the same circuit, really. The other thing I should mention at this stage is why these holes go red when the mouse is on top of them. It's just a reminder that these are the holes which are currently connected together, so they're part of the same node in the circuit. If I put the mouse there, you'll see a small red circle comes around the 0 volts point there, indicating that that is part of this node as well. If I put a wire between there and there, then all of these 5 holes here are connected to all of these 5 holes. They're part of the same node in the circuit. Right. We'll have a look at a slightly more complicated one now. If I just load in this one, you'll see it loads in together with its layout. Oops. You can save and load layouts, including where all the wires and where all the components are. This has come in as a Nucleo Shield design. It's an Arduino Shield compatible device that we use on the Nucleo boards here, and it comes with a little breadboard on top and the pins on the Nucleo's header as well. 5-volt pins, ground pins and everything and so on there. I've put the dual op-amp there. At the moment, I'm using a dual op-amp with the dual op-amp checked there. So despite the fact that there are two op-amps in the design, they only come through as one component, a dual op-amp component. Now, if I powered one of these op-amps from 5 volts, actually let's power them from 6 volts instead, because that's going to be a bit of a problem. And press load components again and hit check design. Now we've got a problem. And the problem we've got is that you cannot power the op-amp here from 6 volts. It's currently being powered via this black wire from 3 volts. There is no 6 volts connection block here. If you're using a Nucleo Shield or the Microbit Edge breadboard, you don't get a connection block. It's assumed that all of the inputs and outputs, including the power, come from the connections from the Nucleo or the Microbit. So it would be a circuit that's impossible to build. If they were 5 volts, however, it would be possible to build. If I hit check design here, it says they're wrong. But if I move the power supply to the 5 volts input, it's now happy again, because I do have a 5 volt signal on the Nucleo board. Capacitors look like this. You can drag them around like this. You can make the leads extremely long, much longer than the leads on the real component. That's not a good idea. You wouldn't be able to build something like that. So again, it's a good idea to keep the component leads short if you can. Right, I think the only other thing I want to discuss is stripboard technique. When you go into the stripboard mode, a 16 by 10 hole stripboard appears. Now you'll see that both the front view, that's the one on the left, and the back view, that's the one on the right, are available. The front is where you place the components. The back is where you make the soldered joints and also make any breaks in the tracks if you should need them. And you probably will. Let's load the components in. Now you'll see we have a connection bar that's come in for the external connections to 0 volts, 3 volts, A0, 1 and 2 in this case. We can't see the resistor, that's because it's just off the screen. Sometimes you have to zoom out a bit to see all of the components. We'll grab the resistor there, and so we can zoom back in again. Okay, now if I put the op-amp on the board directly, like that, we have a bit of a problem, because pin 1 of the op-amp here would be directly connected to pin 8 of the op-amp there, because they're both on the same row of the stripboard. They're both connected to this strip of copper here. Same problem with pins 2 and 7, 3 and 6, and 4 and 5. Now the way we solve that is by putting breaks in the stripboard tracks. And there's a special tool that you can use to do that. In terms of the layout feature of dasim, you double click on the hole. That produces a break in the track there. So now pin 8 there is no longer connected to pin 1. You may notice also that this hole here on the front corresponds to this hole here on the back. If I was to place a wire there, down to here, it's these two holes on the back that would be filled up with solder. The idea is that this represents the front view as you would see it. And then if you turned the stripboard over, you would see this on the back. So these holes on this side here are the same as these holes on this edge here when you're looking at the front. Let's get rid of that wire for now. We'll also have to do breaks in the other 3 tracks here, so we don't have any short circuit between the pins of our op-amp. Next, well, the op-amp needs power, so pin 4 goes to 0 volts and pin 8 goes up to 3 volts. The input comes from A2, that's into the non-inverting input of one side of the op-amp. This op-amp is a voltage follower, so it needs a connection between its output and its inverting input. And then it goes through a resistor, a 1K resistor, to the non-inverting input of the next op-amp. And I'm going to put the resistor down there. I could put one lead of the resistor there and the other lead up there. That should do. That way I can keep the resistor flush to the board. I also need an output going to a note from this output of this op-amp here, and an output from the other op-amp, that would be pin 7 to A1. This op-amp is a voltage follower as well, so little wire between the output and the inverting input. And the only component left to fit is the capacitor. Now the capacitor here needs to go between the non-inverting input, that's there, and ground. Now ground is over here in the circuit at the moment, so what I'll do there is I'll put the capacitor on those two adjacent holes. The capacitor will like that, because the two leads on that capacitor body themselves are just about 0.1 inch apart. These holes on a strip board are on a 0.1 inch spacing. So that spacing will allow me to fit the capacitor very close flush to the board. I can then just add a little wire in there to connect up these two rows together, which connects up this pin of the capacitor to ground. And that should be me done. I can check the design. Yep, no issues found, it's fine. And once I've built the board and I turn it over, it should look like this on the back. There's one other thing I forgot to mention earlier, which is about moving components once they've been placed on a breadboard. If I take this resistor here, place it on the breadboard there, the leads will connect to the holes in the breadboard, and if I pick up the resistor body and drag it, the leads remain fixed into their holes. Now, if you want to move a resistor in a breadboard, that's a little bit annoying because it means you'd have to move the resistor body and then go back and move both of the resistor leads. So if you press Shift while you pick up the component, then the leads detach and they move with the component. They don't stay where they are. So Shift drag moves the components with its leads, just drag moves the component body but leaves the leads connected to the holes where they are. That can save a bit of time. Okay, I think that's just about all I have to say about the layout features of dasim.